Okay, students. Here, most of the metals are highly reactive. When they are highly reactive, they combine with different um, elements like oxides, sulfides, carbonates. They available in different forms. So we have to extract metal from the different composition. Avni, okay, you can off. Okay. So for that, sometimes scientific methods we will use, sometimes technical methods we'll use. Whatever the methods we apply to extract the metal from the ore is called metallurgy. The scientific and technical methods which are used to extract metal from the ore is called metallurgy. Next one, here I am going to introduce some terms. Mineral. What is mineral, student? Mineral means naturally occurring substance. It is a naturally occurring substance, contains metal or it carries metal. Those are called minerals. Here, one more thing, ore I will give. After giving ore, you can make out what is mineral exactly. What is the difference between ore and mineral, students? You had in
It's raw. It is a raw form of a metal.
it is the
A raw form of the metal. So we have to refine it for getting the.
no. I am asking you what is the difference between mineral and ore?
Ore has higher concentration of metal.
Higher,
And also chemical difference is also there some places.
in which way?
A mineral is more purer comparing to ore.
Now ore is like a subset of minerals.
Yes,
From ore, metals are extracted.
see, yes, correct, Dhruva. See, from some minerals we can comfortably extract metal. From some minerals we can extract metal comfortably, means economically profitable way, and it is easy to extract metal. But some minerals, if, extraction is difficult and sometimes it is highly expensive. In that case, that mineral we cannot consider it is a ore. Understood? It should be means extraction should be comfortable, at the same time it should be profitable, otherwise no use. So from this what we can say, all minerals cannot act as ores. All minerals cannot act as ores, but all ores come under minerals. All ores are minerals, but all minerals are not ores. Okay. Mineral from which economically profitably. It's called ore. That is called ore. Next one, gang. Do you know, students, what is GAN?
It is like ore minus metal.
Ore minus
Metal. Like whatever is remaining after metallurgy, once you separate the metal.
the impurities present in the ore.
Yeah.
Generally, we are extracting metal. We are extracting ores from earth crust. No, they contain basic impurities: sand, clay, mud, and all. Those are all simply we call GAN. What is flux, students? In the 8th standard, you had all those things, I think. Flux, slag.
I don't think.
Is there. Suppose impurity, some chemical impurities like silica, if it is present, we'll add basic substance to extract it in fusible complex, fusible form. Or if iron oxide is there, sorry, we'll add silica to extract it. Don't have, you didn't have this one.
No, sir.
Okay, no problem. So here, suppose iron contain generally silica as impurity. Iron ore contains silica as impurity. We want to remove silica. Simply, we can't remove silica. For that reason, limestone we are adding. So at high temperature, limestone is converting into calcium oxide and carbon dioxide. Here, calcium oxide acts as a flux. First, with example, I'll explain. Flux. What it does? Here, calcium oxide reacts with the silica and forms calcium silicate. It is like a fusible substance and less denser. It floats on the surface of the metal ore. That ore is there, no particles. So easily we can separate it. This is a fusible complex. We can remove it easily. We can separate out easily. It floats on the surface of crude metallic solutions. So now what we say flux means the additional substance which is used to remove impurities in the form of fusible compounds. Substance used to remove impurities in the form of fusible compounds. Fusible compounds. You must see here, since impurity is acidic, we are using basic flux. Impurity is acidic, we are using basic flux. If impurity is basic, like iron oxide and all, we'll use acidic flux. Based on the nature of impurities, we'll select. So now iron silicate form. So this is called slag. Fusible complex form or compound form by the combination of impurity and flux is called slag. This one also slag. So here flux classified into acidic flux, basic flux. If impurities are basic, we'll use acidic flux. If impurities are basic, we'll use acidic. Next. So I'll give you a list of important ores here. It's very, very important, students, because sometimes they are asking like Galena is the ore of. Without knowing formula, you can't answer those questions. Or some methods like froth, flotation, roasting, applicable for only particular types of ores. Questions they may ask like this: roasting is used for, or froth flotation is used for. Like that, if they ask, actually roasting and froth flotation is used used for sulfide ores. If you don't know which is sulfide ore in the given names, you can't answer such questions, such type of questions. So I'll give according to the groups: sulfide ores, oxide ores, like that I will give. In the same way you copy it. List of important ores. I'll start with oxide ores. Al2, first name I'll write, then bauxite. Formula is Al2O3 2H2O. Al2O3 2H2O. Next one, magnetite. Fe3O4, iron ore. Hematite. Fe2O3. Zinc-site. ZNO. Cassiterite. SNO. So like this they are asking SNO2. See students, cassiterite is the ore of. If you know SNO2, you can write it as a tin. Zinc side is the ore of zinc. These are the important oxide ores. Next one, carbonate ores. Carbonate ores. Siderite. FeCO3. Limestone. CaCO3. Dolomite. MgCO3. CaCO3. ZnCO3. Aluminum. Zinc carbon. These are the main zinc ores. Sorry, carbonate ores. Done, students?
So in dolomite, why is there MgCO3 and CaCO?
Two carbonates are there, mixed one. Remember, like double carbonates, dolomite. Two are there in that composition. Both are there.
So you can extract both of them.
Both of them, if you extract again, one will be the impurity, right? We'll use separate methods to extract those metals. Once if we get magnesium, calcium, by using boiling, distillation or liquefaction, we will separate it. And it is not the best, better than this, we have other ores to extract metal, magnesium or calcium. Next one, halide ores. Halide ores. NaCl. Rock salt. NaCl, rock salt. Next one, MgCl2, KCl, MgCl2, 6H2O. What is the name of this ore, students? What is the name of this ore? Carnallite. 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 Next one, CaF2. Fluorophore. Na3AlF6. Cryolite. Cryolite. These are the halide ores. Next type is sulfide ores. Sulfide ores. Lead sulfide. Name of this ore is galena. Galena is the ore of lead. Cinnabar. Mercuric sulfide. Zinc blend. ZNS. Copper pyrites. CuFeS2. Only pyrites if they give. Pyrite if they give Cu2S. These are the important ores of sulfide. Important sulfide ores. Done, students? and other ores like copper and all. CuCO3, CuOH twice. CuCO3, CuOH twice. Name of this ore is malachite. Malachite. MgCO3 is called magnesite. Okay, these are the important ores. These formula you have to know, students. Magnesite. Native form, combined form. No need to write this one. Just I will explain orally. Which type of metals available in native form, students? Which type of metals available in native form? Native form means original form. Yeah.
Copper,
Copper. Any other example? Dhruva disappeared.
Silver, I said.
Silver.
Gold, platinum.
Why?
They don't react with other like elements and they don't form ores. They are formed like pure
Right.
in nature.
Silver, gold, copper, sometimes, most of the times, mercury also available in native form. These are less reactive or least reactive. So they are available, they won't combine with other elements. So they are available in native form. So what we can say, least reactive elements available in native form. Platinum also. Least reactive elements available in native form. Metals or elements available in native form. Example, silver, gold, etc. Next one, combined form. Combined form. Highly reactive metals available in combined form. Highly reactive metals available in combined form. Generally, first group elements, second group elements, some transition elements also. They available in combined form. They are highly reactive. They won't available in native form. They available in combined form. Okay, students, now we'll start metallurgical process. Metallurgy. Here there are some stages, students. In 4 stages it happens. What are those 4 stages? First, conversion of the ore into powdered form. That is called pulverization. From that stage, concentration of the ore. First stage is concentration of the ore. Concentration of the ore. Second one is conversion of concentrated ore into oxide form. Conversion of concentrated ore into oxide form. Third one, reduction of oxide ore into crude metal. Into crude metal. And the last one is refining process. Refining process. These are the main main steps. First stage is concentration of the ore. In concentration of the ore, which type of ores we are separating, which type of impurities we are separating, students? Earthy impurities, basic impurities or primary impurities present in the ore are separated in concentration of the ore. Earthy impurities like clay, mud, sand and all will remove in first stage, concentration of the ore. Second stage is, once if it is free from all the basic impurities, we will convert different forms of the ore into oxide form. Different forms of the ore into oxide form. Listen, students. See here, suppose if it is in sulfide form or other form, any other forms, extracting metal from the sulfide or any other forms, it is difficult, quite difficult. If we convert it into oxide form, we can use different reduction process. We can remove oxygen by using suitable reducing agents or by heating or by applying electricity. We can remove oxygen from the metal. In that metal oxide, we can separate oxygen easily. Other case, reactivity is more and gives free energy. We will tell that you don't know, that is beyond your scope now. Don't want. So removal of or extracting metal from the sulfides or any other forms, it is quite difficult. Directly we can't extract metal from the other forms. So we are converting carbonates, hydroxides or sulfides or any other forms. We are converting into oxide form first. Oxide form. In third stage, we are removing oxygen. Oxygen. Okay, students. Why we are converting sulfides and all into oxides? Removal of oxygen is easier compared to other groups. That is the reason we are converting into oxide form. Next, here reduction also. Here each and every process depends on nature of the impurity and nature of the ore. Nature of the impurity and nature of the metal or nature of the ore. Depends on. So according to nature of the ore, we will select the process. Okay. In concentration of the ore also, for different ores, we will use different methods. We will see one by one. First one, first side heading, concentration of the ore. Concentration of the ore. In concentration of the ore, there are some methods. One is hydraulic washing. Second one is magnetic separation method. Third one is froth flotation. Froth flotation process. So depends on nature of the ore and nature of the impurities, we will select the methods. Hydraulic washing, magnetic separation method, froth flotation process. We will see one by one. So this is the first stage. Leaching also is there, but that this one now I won't teach. Separately we will get leaching process. That time I will teach. See students, this is hydraulic washing. Hydraulic washing, hydraulic washer here. See, from this water we are allowing in powdered ore here. Upon powdered ore, here we are spraying water upon powdered ore. See students, what we say these are grooves, something, no, what we can use, grooves. Okay, so when we take powdered ore here and if we pass or if we spray water upon that, these denser ore particles will settle down here. Denser ore particles will settle down here, and this lighter earthy impurities are there. They mix with water and they flow like this. This is like inclined position, like this it is. So this water will carry earthy impurities.
Do you increase the size of the?
Sorry.
Can you increase the size of the image? Thank you.
No. Can you see now? Why is it okay now?
Yes.
Yes, sir.
So it's a simple process. This is also called gravity separation method. Gravity separation method because it is depends on the differences in densities of the ore and impurities. Densities of the ore and impurities. These heavy denser ore particles are settling here in the grooves, and lighter earthy impurities are flowing in the water in the form of mud water. So here gangue particles separated and ore particles settle here. I told for denser ores we are using this one. Generally for oxide ores of heavy metals we will use lead, iron oxide also. Ores of lead, iron. For iron we can use magnetic separation method. This one also we can use. Generally oxide ores can be concentrated by using this method. Leaching chemical process, Ravan, but that I will give in a separate metallurgy is there. That time I will give. Silver metallurgy, gold metallurgy is there. That at that time I will teach. So which type of ores can be concentrate? This method lead, tin also. By this method. Next one, magnetic separation method. Magnetic separation method. See, by seeing the diagram only you can understand. These processes are very easy. This here powdered ore we are passing. These are the magnetic rollers. Mention magnetic rollers, and powdered ore we are passing upon this. This conveyor. This is called conveyor belt, which is connecting to magnetic rollers. It is rotating. It carries ore particles. Here, in this basic principle is either or condition, either ore or impurity, any one must be magnetic. Any one must be magnetic. Then only this method we can apply. So magnetic substance can attracted to the magnetic field. Non-magnetic substance will move far away from the magnetic roller. Magnetic substance get attracted to the magnetic field. Non-magnetic substance will move away from the magnetic roller. In this way, we can separate magnetic and non-magnetic substances. So this one is used when either magnetic, either ore or impurity, any one must be magnetic. Any one must be magnetic in that condition only. Generally, iron, nickel, manganese ores can be concentrated by using this method. Manganese, can be concentrated by using, these are the magnetic ores. Mining basics and all won't be there, just your basic methods only they'll give. Done, students?
Yes, sir.
So hydraulic washing is used for heavier metallic oxide ores. Magnetic separation method is used for magnetic ores, or if it contain magnetic impurities also, we will use this method, magnetic separation method. And this one is very, very important, students. Froth flotation. Froth flotation. Put side heading. Froth flotation. Should I make it big? I think you can see now. Is it visible, students? Words and all?
Sir, some of the text is hidden.
No. Nothing. Froth bubbles. Is it okay? Is it visible, students?
Yes, sir.
Okay, ma'am. This is called froth flotation. First, I will explain these things. Is anyway container. Here, what and all chemicals we are adding? Sulfide ores. Generally, in froth flotation method, which type of note down these points, friends. In froth flotation method, or like this, right now, sulfide ores can be concentrated by this method. Sulfide ores can be concentrated by this method. Why sulfide ores? Only concentrated
It's
by
very
this.
light,
Ma?
less dense.
Very good. Sulfide ores are less denser. Sulfide ores are less denser. Here, this one, solvent or liquid, water and all we have taken, water and pine oil. You know, RQ impurities can wet by water. but metal ore particles we will not wet by water. So to wet earthy impurities, we are adding water. To wet ore particles, we are using pine oil. And pine oil enhance the non-wettability of ore particles from water. Enhances the non-wettability of ore particles. Because of the two reasons, we are using pine oil. Two pine oil or fatty acids we are using along with water. So somehow by using these two liquids, we are making one suspension. Next, this one is rotating pedal, and we are passing hot air through this. So when we agitate this mixture by using rotating pedal, slowly froth generates and it moves towards the surface or most upward direction. Students, rotating pedal and compressed air we are passing. Rotating pedal through this rotating pedal, when we agitate the mixture, slowly froth is developing and it is moving towards upward direction. This froth carries sulfide ores. Here it is there. Froth, froth bubbles carrying sulfide ore particles, and heavy earthy impurities are settling at the bottom of the container. Settling at the bottom of the container. So here, principle, if they ask what you have to write, students, froth flotation method is depends on, yes, it is only for sulfide ores. Froth flotation method is based on the differences in wettabilities of ore and impurities. Differences in wettabilities of ore and impurities. Impurities. This I told you, once if we agitate the mixture, automatically froth generates, it moves upward direction. Every time we have to remove this froth, it will be skimmed off. And one more thing, this froth is not much stable. Again, it will dissolve in the solvents. So to stabilize the froth, we are adding froth stabilizers. Aniline. Froth stabilizers we are adding, aniline xanthates we are adding to stabilize the froth. Otherwise, again, if it dissolves, same process we have to continue. So to stabilize the froth without dissolving in the liquid, we are using froth stabilizers. So this pine oil is called collector. Which is enhancing the non-wettability of the ore.
Yes, sir.
This process, powdered ore of powdered sulfide ore we are taking. To the powdered sulfide ore, we are adding pine oil and water. Water wets earthy impurities, pine oil wets the sulfide ore. So by using these two liquids, we are making suspension of this mixture. After passing compressed air and when we agitate the mixture, froth flotation. I had given in the beginning types. Samat. So froth generate. It's like buttermilk preparation. You remember buttermilk preparation. They'll generate now. So this is based on the differences in wettabilities of the ore. Differences in wettabilities of the ore and impurities. I told here froth stabilizers, froth collectors. collectors, fine oil, fatty acids we are using, froth stabilizers. After forming the froth, to stabilize that froth, we are using froth stabilizers. Those are aniline and creosotes. Froth flotation spelling you want. Very, very important students. So different applications they are asking upon this. Next, one more important point, students. So last year, 2 years back, many students, second year students, lost marks in this. Zinc sulfide and lead sulfide. These two are very close friends. Yeah, sometimes zinc sulfide contain lead sulfide contain zinc sulfide. So if mixture of sulfide ores are there, how to separate? How to separate? For that, we are using depressants. Depressants. Depressants like NaCN, KCN, if you add, they separate. In this, one is lighter sulfide ore, it is little bit higher, denser ore, sulfide ore. So NaCN or KCN, if you add, they allow selectively only one sulfide into the froth. Only one sulfide into the froth by preventing other sulfide ore. So what is the function of depressants they are asking? If they ask function of depressants, write to separate the mixture of sulfide ores. To separate a mixture of sulfide ores. Depressants are used to separate the mixture of sulfide ores. In this, NaCN or KCN allows only lead sulfide ore by preventing this point also right now. NaCN or KCN or depressants allows only lead sulfide ore into the froth by preventing zinc sulfide ore. Zinc sulfide ore. This is the function of depressants. Function of depressants. Aniline. Have you seen benzene, students? This is benzene with NH2. This is aniline. Creosotes means phenol with methyl group. That and all structures don't want names, you remember. Next, second stage. What is the second stage, students? Conversion of, now by using above methods, we can remove earthy impurities. Earthy impurities. Now, second stage is conversion of concentrated ore into oxide ore. Conversion of concentrated ore into oxide ore. Conversion of concentrated ore into oxide ore. Here also there are two methods. One is Calcination. What is calcination, students? Calcination. Calcination is nothing but heating of carbonate or hydroxide or hydroxide or in the absence of air. See here, calcium carbonate on heating, it converts to oxide and carbon dioxide. Like this hydrated forms, Fe2O3, XH2O, if any hydrated form of oxides are there, they converted to anhydrous form, ZnCO3. On heating in the absence of air, they converted to heating of carbonate ore in the absence of air is called calcination. Is called calcination. Here you just see carbonate ores are converting into oxide ores, any hydrated form or hydroxides also converting into oxides. It's calcination method. Any other volatile impurities also removes in this method. Calcination. It is very simple. Next one is roasting. Previous slide. Okay. Next one, roasting. Heating of sulfide ores in the presence of oxygen. This one is only for sulfide ores. Is called roasting. Look at side, students. Lead sulfide on heating in the presence of oxygen gives lead oxide plus SO2. ZnS plus O2 in the presence of ZnO plus SO2. Like this. So this is used for only sulfide ores. Roasting is used for sulfide ores. If it is having any other non-metallic no, impurities like phosphorus, in the presence of oxygen, they separate, they become P2O5. Any nitrogen oxides, anything, if impurities, non-metallic oxides are there, non-metals are there, they convert into respective oxides and they remove. There will be outlet in this reverberatory furnace. It takes place. There is outlet at the top. They will these waste gases and all will be separated through the outlet. So conversion of sulfide ore into oxide ore in the presence of oxygen. So anyway, sulfide ore we mentioned now. Roasting is used for only sulfide ores. This is the second stage. In second stage, if they are most of the metals are available in the form of carbonates or sulfides. For carbonates or hydrated oxides, we are using calcination process. If it is sulfide ore, we are using roasting process. Anyway, in both process, we are converting ores into oxide form, different forms of ores into oxide form. We can remove oxygen easily by using reducing agents. So we are converting concentrated ore into oxide form. Third one is third stage. Reduction of oxide ore into crude metal. Reduction of oxide ore into crude metal. This process is called smelting. This process is called smelting. Reduction of, so in first stage, we removed earthy impurities. Second stage, we converted concentrated ore into oxide form. In third stage, we are removing oxides, reduction of oxides. See students, metallic oxide by using carbon or carbon monoxide or any other reagents, hydrogen, aluminum, and all we'll use. So here, converted to crude metal, carbon is converting into carbon monoxide by accepting the oxygen from metal oxide. Here also same thing, CO2. Fe2O3 on reaction with carbon converted to 2Fe plus 3CO. Or FeO, carbon monoxide also can reduce, Fe plus CO2. ZNO plus carbon is Zn plus carbon monoxide. Using carbon or carbon monoxide reducing agents, we are reducing metal oxides into crude metals. And one more thing, students, in which case carbon or carbon monoxide we can use the reducing agents for moderately reactive metals. Moderate, right? No, this point also. Moderately reactive metals. These are not very high reactive. At the same time, these are not least reactive also. Moderate reactive elements. We are using this method. This method is also, these and all come under pyrometallurgy. Next. Cr2O3 or Mn3O4. These oxides, we can also use aluminum. Aluminum can reduce these oxides. Otherwise, you put aluminum as reducing agent. See students, here it forms Al2O3 and chromium will come out. Here lot of heat releases in aluminum reactions, large amount of heat releases. So these reactions are called thermite reactions. Thermo means heat, lot of heat is releasing. So these reactions are called O3 plus Mn plus heat you put students. These reactions are called thermite reactions. Thermite reactions. Auto reduction or self reduction side heading. Import star marks you put and write. Auto reduction or self reduction. Some oxide ores themselves they reduce to respective metals without any external reducing agent, without using reducing agent only. They convert into metals. Those that reduction is called self reduction. Questions how they are asking. Among the following, which is undergoing self reduction? Which is undergoing self reduction? All these points you just make notes, students. However, they ask your examinations, almost NEET level and all, it's covering. Second year also, no need to learn once again. Once if you go through this one. Second year also, most of the things are covering here only. Self reduction or auto reduction. Auto reduction. See students, some metal oxides like mercury, copper, lead, etc. They undergo auto reduction. Auto reduction means, see here, Cu2, yes. In roasting, what happens, students? Cu2O plus SO2. This Cu2O is there, no? It reacts with the excess of copper sulfide. Again, it will react with excess of sulfide, converted to Cu plus SO2. Six Cu SO2 balanced. See, here we have not used any reducing agent. Only copper sulfide converted to copper oxide. Again, it reacts with copper sulfide and gives copper. This reduction is called auto reduction or self reduction. We are not using any external agency. Yeah, external reducing agent. Even mercury sulfide also. Converting into mercury oxide plus SO2. Mercury oxide reacts with HGS. SO2. Questions how they are asking, among the following, which undergoes self reduction?